Hey everyone, today we will talk about how to design a real-time chat service. So let's get started. Let's talk about functional requirements. A user should be able to send a message to another user or a group of users. The system should be able to show online or offline statuses of users. A user should be able to upload images and videos in addition to text messages. A user should be able to receive a push notification when there are new messages. Senders should be able to get a receipt when receivers read messages they sent. Okay, so let's talk about non-functional requirements now. This system should be having very low latency. Also, this system should be highly available. Okay, now let's talk about the design. Let's say there are two users who want to chat with each other. We need a chat service and a database which stores chat messages, its delivery status, and read receipts primarily. Since we need to provide a real-time message delivery experience, we would require a mechanism to push messages from server to client, rather client pulling the messages from server, right? That is why using WebSockets would be the best choice here. Okay. Now let's go deeper and understand the end-to-end communication tool. Once user and user 2 gets logged in and connected to ChatSync plus WebSocket service, WebSocket service will primarily assign a WebSocket server to each user. Now let's say both users are online and connected to two different WebSocket servers. WebSocket service will receive message from user 1, which is intended for user 2. Now this service will store the message in chat message DB and mark the status as sent, which means the message is received by the server but undelivered. It will also notify user 1 saying, hey, the message is received by server via push notification service. Now, uh, the service needs to maintain a WebSocket server's mapping in the cache for each of the online user in order to understand which user is connected to which WebSocket server. So that uh, this could check quickly whether user 2 is connected to any WebSocket. If yes, it will forward the message to appropriate WebSocket, which would try sending the message to user 2 via that particular WebSocket connection. Okay. Now, what if the user is offline and not connected to any WebSocket? In that case, ChatSync service will just store the message in the DB and notify user 2 via push notification saying, hey, a new message is available. Okay. So primarily notification service is responsible for notifying sender for the delivery status and read receipts, like the message is sent, the message is delivered, the message has been read by the recipient. Okay. And also responsible for notifying recipient for a new messages. Cool. Now, let's talk about how we are going to maintain the information in private chat table. Okay. So let's say uh, sender 1 wants to send a message to sender 2. So we want to have sender ID, receiver ID, message ID, the timestamp at which the message was received by the server, and the message content. Okay. And at a large scale, we might want to shard this particular table. Okay. And we want to use a partition key, which should be a combination of sender ID and receiver ID. And we also want to sort messages with the timestamps. Okay. So message ID need to be timestamp driven, and this need to be the sort key. Cool. Now, what if the WebSocket server at receiver end goes down while user 1 was trying to send message to user 2? Okay, how we are going to handle this? So if user gets disconnected, or let's say WebSocket server gets killed, okay, the chat service would immediately remove user to WebSocket mapping from the cache and also send push notification to user to device client saying, hey, a new message is available. So this way user to device client can pull all new messages from the chat service when the device comes online next time. And even though the user 2 is offline and push notification was not delivered, uh, I mean, the client may request chat service to push undelivered messages when it comes online next time. Okay. Also, once the messages are delivered and read by a recipient, his device client would also send back the delivery status to chat service, which we would be storing in read receipt DB, and this service would have to again forward this uh, message uh, delivery status to user one, which was the sender user, as a push notification. Good. So, so far we have done a good job designing a private chat service. Now there's one more challenge. How can we handle high volume writes from chat sync service to chat message DB? So the solution here is to use message queue in order to write chat messages and read receipts in chat DB asynchronously via message queue to handle huge load. But this may create some delay. And meanwhile, let's say if recipient was notified for some message, hey, user one has sent some message for you. Okay. But when user goes to the app and tries to pull this data, that message was actually not available in DB, and that message was still in the queue. So the client should show something like, hey, waiting for message. Okay, this can happen. Okay. But this should be fine as it happens momentarily only when the uh, traffic is very high. Okay. But the advantage is our database doesn't get choked at this kind of high traffic. Cool. Now, we also need to think of how to make messages ID time sorted. Okay. This can be done by including server timestamp into this. For example, sender ID underscore receiver ID underscore the timestamp for which at which the message arrived at server. And similarly, sender ID underscore group ID underscore timestamp for which at which the message arrived at server. Okay, cool. Now, uh, we need to think how we can notify recipient when sender is still typing. Okay, I mean, we need to share some sort of a typing indication. Okay, how we can do this? We can do this by sharing typing uh, message as a form of message only via WebSocket connection itself. Okay. And this is pretty easy, but uh, doing this for group chats, right, would be a very expensive operation because we would have to compute all the users, and every time user starts typing something, we would have to fan out to all the users separately. So, in order to uh, reduce load for such operations, we might need to restrict sending typing indication message via WebSocket within private chats only and not for group chats. Okay. And now, when a user tries to send a message in a group, okay, let's talk about group chat. Uh, we need to send message to all the users in the group in particular channel via WebSocket individually, but pushing new message for group again would put a huge load on web servers due to a lot of intercommunication. So to handle this situation, we may choose to push private chat messages only via WebSockets. Uh, while for group chats, we might want to notify all the users, hey, to pull new message from chat sync server separately. Now, chat sync service might save sender's message against specific group ID in the group chat table and ask group management service to provide list of all users who are part of this group in order to notify them. And here group chat users would be pulling this data in order to uh, improve the performance of towards WebSocket intercommunication, and this will be very beneficial. Okay. Now, to understand who all users are participant of a group, or who or a user is part of which all groups, right? We need to maintain such relationships in group membership and user membership table in the DB. We can notify group level changes also, like somebody joined, somebody left, somebody is admin now for the group, or somebody was removed from the group, kind of activities at a group level via push notification only from this group management services. Now we also need to maintain user profile. We also need to maintain last seen, online, offline status. This is something which we can have in the cache. Okay. And in terms of having blocked contacts uh, stored somewhere, we need to have these stored in the DB. So whenever chat sync service needs to send a message to some user, it first check whether this user comes under the block list or not. Okay. Now there is one challenge. We may need to ensure all messages are delivered in the same order as of they were sent. How can we do this? We can do this by attaching a previous message ID with new message ID. And this uh, way, even if some of the intermediate messages were missed while delivering, client can quickly check whether the previous ID received by the server matches with the local device label previous message ID. If yes, it's fine. The chat history is in the sync. If not, this means we need to pull some of the intermediate messages, and client can request server to uh, sync the chat history again. Okay. Cool. And this is just to ensure the chat history remains consistent for all the users. Also, we would have to extend our private chat and group chat table to allow users attaching a media, or let's say an old message in the chat history with a new message which is being sent. Now, if media is attached to a message, first media service uploads the raw media and saves the metadata like sender ID, upload time, etc. And would notify compression workers to pick this media for post-upload processing. Okay. Compression workers pick the media from raw media store, compresses and saved in compressed media store, updates the pre-signed CDN URL also in the metadata, and then once the job is finished, compression workers also notify back uh, to the media upload service saying, hey, the compression job is done, and then media service shares this particular uh, media CDN URL back to the device client user sender device client. Okay. Now sender device again call chat sync server saying, hey, this is the message content and this is the media, and please process this further. Okay. So the idea is uh, chat sync server again do the same stuff which it was doing earlier. Okay. Now it has a CDN URL attached to the message. Uh, Also, think of a situation where media can be forwarded from one group to other. Okay. Obviously, every time we forward a message to a new group, a new message ID would be created, but the CDN URL would be the same, and we need not to involve uh, media service into this. Okay. So sharing media content will always have a message ID, but may or may not have the text content always. Cool. So this is how we have designed the system. Okay. Uh, Hope you really like this video. Please like, share, subscribe. Also feel free to comment if you have any questions. Thank you.